And hopefully at the end, we can also do a little case study where you're involved. So my name is Steve Mackay, Dr. Heidi Hart, self-based in a tick. And very keen about engineering and education. And the last 3 or 4 years, I've spent quite a bit of time with AI, with various projects. And I'm actually from Australia, although if you listen carefully to my accent, I've only been there 40 years. But we've also got a college here in Stevenage, and very grateful to the IET for allowing us to use these great facilities. And you'll be hearing a lot more of us either online or in these regular sessions where we're going to take particular topics. And we've been doing it online for years and years and years from Australia. But now that we've been accredited for engineering degrees in the UK, we'll obviously be doing more here as well. So this is one of our first launches. And I think AI is going to be a key tool, but there's obviously a lot of issues which we'll discuss shortly. So that's me, and I've got my intrepid, long-suffering colleague, Dr. Heidi Hart, who's been presenting us for, I think, 15 years from Barcelona, and he does a lot of our master degree programs, and I think he's even supervising our professional doctorate students, and highly esteemed. And he also is an entrepreneur with his own engineering projects. I think it's a cheese factory. But anyway, over to you, Heidi.
Okay, hi everyone. So, well, I've been in AI since the year 2000 or so. I started by founding a company in France about music recognition, music recommendation, and media recommendation in general. So I founded this company back in 2005, and then was dealing with AI as an engineer, as a researcher, as an entrepreneur, as a lecturer, as a consultant. And it's been like more than 10 years where I work with EIT as a lecturer. So this is a bit from about myself. Thank you.
Thanks very much, Heidi. Really appreciate it. And Heidi is very inspirational and has been driving a lot of our mainly industrial automation, process control education. So very passionate. Thanks, Heidi. And Heidi will be joining us in a tick again with some of the sessions where some of his projects. Okay, so I'll just also say there's a few of our staff here as well. So welcome here, ECT staff, all part of the group here. And the Engineering College of Technology, we've obviously got a bit of a introduction. I don't know if Caroline wants to introduce you.
Introduction of who?
The Australian.
Hello to all the online attendees as well. So basically, EIT has been around for over 30 years, based in Australia, offering Australian accredited qualifications. And more recently, we've launched the Engineering College of Technology, which is based here in Stevenage. And we offer 4 UK recognised qualifications, 2 bachelors and 2 masters. We're all very passionate about engineering education and also making sure that it's accessible to people around the globe. And also very industry focused, and we've got students from over 160 countries around the globe studying with us. We've even had someone studying with us from Antarctica, and they had to go there for their job. So a little bit of an insight into who we are.
Thanks, Caroline. Yeah, so we're obviously not silly enough to try and compete directly with universities in the UK. There's some very good programs which you've obviously been on. We are obviously running online engineering, so it's a complete paradigm shift. And we target our students are generally mature age professionals, so they're working in industry. And at the end of the day, we believe in the not Mr. T's comment from the White House about drill, baby, drill. I always say we believe in jobs, baby, jobs. It's all about getting high quality jobs. That's what matters. James is going to be using AHA slides, and we'll be expecting, if you can, use your phone when it comes to interacting so we can get a profile. And also to all the wonderful online attendees, please make sure you've got your phone handy, and we'll be using the AHA slides to do some interactive discussions, just to get a profile of who's here and who's online in the cloud. And as I said, we're not going to go through every slide, but they will be provided to you, and we've done this presentation many, many times. Obviously, issues to keep updating it because of the rapid change, but it is really an exciting space, and a space with lots of issues as well. So we'll hopefully then, and obviously I would love your feedback. So if you have any comments now, please shout. And I'm very keen to talk one-to-one. Don't worry about interacting with us. If you disagree with something, hopefully, then no problems at all. Just from a safety aspect, to get out of this building quickly, straight down the corridor, and then left, and there's a emergency meeting place outside. Toilets are straight through and out to the right, and obviously just make sure if you leave at any time, that's fine. That's this is at your convenience, this presentation. And then we'll have, this session will last for about an hour and about 15 minutes, hopefully with interaction with the case studies. And we will break afterwards for snacks and snacks here. So it'll be about an hour and 15, hour and 20 minutes. So as I said, hopefully interactive.
And just a note, please help yourself to tea, coffee, just pop out and grab yourself.
Coffee, and there's orange juice.
Some water at the back here.
Okay, let me get the AHA slide.
So just to get an idea of who's who in the zoo, or who's who in Stevenage and online. We just want to get an idea of who you are. So James is going to run a AHA slides, which gives us a little bit of a profile. We'll provide everyone with a copy of who's who here as well. And also, I just want to say thanks to our team, Barry, who's managing it. Say hello, Barry.
Hi, everyone. Thanks, Steve.
Thanks, Barry. And we've got a few others, Leah, and the others joining us as well, managing it. Over to you. So if you can explain what they need to do.
Sure. So I probably should mention, forgive me, I should have said this right in the beginning. There is actually free Wi-Fi in this venue. So if you see the Wi-Fi name EIT guest, it should be unsecure. You can click that Wi-Fi name. It will take you to a website where you can enter. You just have to accept the terms, and then you get free Wi-Fi if you need. So you can connect to that if you don't want to use your data. Now, I see people have already jumped on. So essentially, I'm going to ask some questions, and the way that this works is that you need to get your phone out, and then ideally you scan that QR code. It will take you to a website. This will take you to the page here, and then you need to enter. You can enter responses in as a result of based on what the question is. So the first question is, what type of engineering professional are you? So if everyone can get their phones out, scan the QR code, and then try and enter a response, that'd be fantastic, and they'll pop up in real time here. Now, if the QR code doesn't work, you can also go to that website there on the bottom left. It's just ahaslides.com/, make sure it's cap sensitive as well, capital TBDFA, and then you can enter your responses here. So we'll do this twice throughout this session.
And this is not a scam site or spam site or whatever site. So don't worry, those online, you don't need to join if you don't want to, but it just gives a bit of a profile. It gives an idea of who your peers are in the rooms, which is always nice to know.
May I ask, Barry, can everyone online also see this screen?
Yes. Thanks, James. Yes.
Okay, fantastic. Cool.
Thanks, Barry.
Steve, can you read out some of the ones that are more difficult to read?
Yeah, some of the reasons. So we've got industrial systems, broadcast engineering, electrical engineering, civil engineering, process engineering, mechanical, staff, automation. So it's quite an eclectic group, which is good, brilliant. And this is online and in the room here. So there's probably going to be a lot of people, 50, 60, 80 responses. So unfortunately, we've got quite a lot to go through, so we'll be very quick. We'll just give you the time to do this, and you can see the general electrical engineering, industrial and systems, ECT course advisor.
James, can we send these slides out to the attendees?
Of course, yeah, we'll send the results out after, yeah.
Okay, they can still type it in after we go to the next slide.
Next one.
Yeah, just okay. We'll just go on to the next slide. So you can see quite a varied group. What is your current job title?
You don't have to scan the QR code, by the way. It should automatically update on your now that you've got it in your browser.
Process engineer, managing director, surveyor. It's an interesting one. Project officer, brilliant. Okay, so as you find, as time goes on, people get quite quick with this. Course advisor, project officer, contractor. Where the hearts come from? Okay, that's an addition, isn't it?
No, it's been there, but someone's very interested in using it.
Okay, thanks for the hearts, everyone. It's really appreciated. And there's another one. What's your highest qualification? So just put down masters, PhD, A levels, O levels, HND, whatever. This again gives a bit of a profile. Bachelor degree, college, BSc mechanical engineering, bachelor degree. Quite a good range of qualifications. Master electromechanics, chartered engineer, BA Hons, good, excellent. Need some.
After my own heart.
We need some artistic input endeavors here. Okay, and then we've got quite a range of people, as you can see here. And as I said, we'll make sure everyone gets a copy of this. It's quite interesting to see the range of people.
Okay, we'll go back to the slides. Barry, if you can just share the slides again, thanks. That'd be good.
So we'll come back to this a bit later. Got a few other questions once we get to the AI section a bit later. And we've got a few issues with Teams. You may be aware of Microsoft Teams. It's not as flexible as we'd like it. So it's a bit clunky at the moment. And as you're aware, Microsoft have been steadily letting lots of people go. So you can see from Teams, but it's a very useful package. But I think it's got a way to go before it's really spot on what we're trying to do with it. So please give it. As I said, you're going to get a copy of the slides, attendance. So everyone online, you'll get a copy of the slides and certificates online attendance. So no worries. So what we're going to do today is obviously just talk quickly about the objective. I'm going to reproduce a slide from one of the universities here as to what they believe is required. I'm going to pass the microphone to my good colleague, Hardy Harb, who will energetically go in and take AI versus machine learning to pieces and also talk at some of the examples of using machine learning and AI. Hopefully you'll see the differences. And then I'm going to come in and talk a little bit about large language models. And we even got one of our staff actually doing a PhD in AI. Maybe she'll contribute, maybe not. I want to then focus on the essentials of AI and ChatGPT, some of the issues you need to know about. Hopefully, most of you have been working with AI, but if you haven't, it doesn't matter. And then we also want to give you a quick demonstration of some of our recent efforts with AI, with our teaching, and just a few seconds there. And then if we've got time, there's about 5 case studies I normally have. We'll try and just do one, and we'll break up into groups, and I want you then to take on a particular problem. And the problems are quite eclectic, ranging from Scotland to Nicathera in Western Australia, and they will be using AI. And I want to get your feedback as to in your little group. So we'll group up. So it's a little bit ambitious for the time available, but we can do it. And then finally a wrap up. So that's where we are. So hopefully by the end of this hour and a half, when you're sitting on the train or stuck in the M25, you will be thinking about a bit of an understanding of AI and machine learning as applied to engineering. Hopefully you'll get a few tips and tricks which you can apply in your work using large language models, and then a few strategies for integrating into work and some of the issues which cause lots of frustration and agony, as they have with me. Like yesterday, I was just trying to do a very simple task with AI with my chum, Philippe. That's my AI chum. My wife thinks I'm deranged. But Philippe said, mate, I give up. You have to get a human to do this. And I was just making 3 simple slides. And it was really a very easy project. But there are issues and there are opportunities with AI, which we'll obviously hopefully consider. So why we need to apply AI? I think this is a great thing from the University of Leeds promotional post. I really enjoyed it. Obviously, being at the forefront of the future, there's huge change occurring. I don't think AI is going to be as wide-ranging as everyone thinks it is. I think, as usual, we'll probably find it'll be a bit lower, but it's certainly going to change our lives and add value and avoid a lot of repetitive work. And then, obviously, address challenges in your sector. There's a lot of challenges which you can use AI to address, and lots of our staff at ECT or EIT use AI every day to look at challenges. Students use it as well, not always with very good results, so we try and educate them on how to use it properly, but obviously there's a few issues of best practice in industry. AI on its own is not going to resolve all your problems, but it can be a good chum to help you work through a lot of the issues. And I think we've got lots of we're faced by great opportunities, which always look like problems. And as someone said to us in the meeting yesterday, mate, what's going to happen to ECT, EIT? This AI is just going to take over the whole teaching facility and we're going to have nothing to do. And it's true. I mean, if you look far in the future, then what's going to happen to us? But it's not. I think there's huge opportunities as a result. And at this point, I'm going to pass on to my good colleague Heidi Harb, Dr. Heidi Harb, to talk about AI versus machine learning. The long-suffering Heidi, over to you, my friend, my compadre you're in Barcelona, eh? Barcelona.
Thank you, Steve. Okay, so a few words on what is AI, what is machine learning, what is deep learning, because we often hear these terms being used. So if you want, AI, artificial intelligence, is making machines that are intelligent, meaning machines that can do things that we humans, we do, solve problems that we solve. And by creating such machines, we augment ourselves. Like when I have a small device that can think like me or even better than me, it's like you are adding a human to your team and you are using it. So this is AI in general. Machine learning is part of AI. Machine learning is in particular to create systems that can learn from data, meaning you just throw at them data, you give them some kind of measurements, you give them some kind of labels, and they will train and they can improve. And this is really a great paradigm shift from traditional programming, where the programmer has to program every case into the software in order to solve problems. In machine learning, you create a kind of general system that will learn like a human, and then you can train it. Which is why we are so great with humans. It's because we can learn. Like a child, a kid will start with an almost kind of white paper, and then it will start learning, and then they become as intelligent as the major, like all humans are. So this is the idea of machine learning. And then you have deep learning. Deep learning is even a part within machine learning, and it's like the latest development in machine learning, inspired by how the human brain works. So inspired by the neural networks that we have in our brains, and modeled on computers, so that you have what's called deep learning. Now, in terms of machine learning, what's the idea? As I mentioned, machine learning is to create systems that can learn from data. So what do you want, or what do you need? You need some kind of data that is labeled, like measurements from a machine. So you take measurements from a machine, sensors data, and then you label these as this measurement, or these measurements are from a situation where there's a fault, these measurements where there's no fault. You provide this data to a model, an algorithm. It will learn to produce that label from the measurements. Once it learns, now you can give it the measurements, give it the data that we are going to call features. You give it the features that are how we represent the situation, and that model will tell you the machine is faulty or it's not faulty. This is, in general, what machine learning is. So I have to provide a set of measurements, or what we call features. I have typically to provide labels, like a category or a number I want to predict, and then the machine learning system will learn. Basically, it will learn in a way similar to we humans would learn, by changing coefficients, by changing interactions between components, or like neurons. And after that, you can use it. Now, in machine learning, you have what's called supervised learning. In supervised learning, you supervise the learning. Think of it like you want to train a child to recognize a car, or differentiate between a car and a pickup truck. So what do? You show that child pictures of cars, and you tell them this is a car. Pictures of pickup trucks, and you tell them this is a pickup truck. So the child is receiving the picture. These are the features. So these are the inputs, the measurements, and you are telling them what's the label, car or a pickup truck. After a few sessions, you show the child a car or a picture of a car. They will tell you this is a car. This is called supervised learning, and this is something that we do in machine learning. The examples I will show you in a moment are about supervised learning. We have also what's called unsupervised learning. Unsupervised learning, we don't have labels. We just provide measurements, and we let the machine try to create clusters. Like here, create clusters. Think of it like you collect data about your users. And the data about your users could be things like, what do they consume on the web? What kind of videos they watch? What kind of keywords they search on the internet? And you run a machine learning system that will cluster these and segment your customers. Now, if you want to recommend some document or some file or some content to a person, you can say, oh, this person is within this group, so let me recommend the same thing to the whole group. This is particularly useful if you are recommending. So you create clusters automatically. And then in the supervised learning, also you can consider what's called classification, where you are providing a label, and what's called a regression, where you want to provide or predict a number. Think of it like you want to predict a precipitation level, like how much precipitation there is every day. This is called regression. You can think of it also as a classification, like you want simply to classify between rainy or non-rainy. Okay, so these are like subcategories of supervised learning. And finally, we have reinforcement learning, which is like how we humans, we learn, or animals would learn. We try things. If we do it right, we get a reward from the environment. Like AI tastes something, if it tastes sweet, I'm going to like it. I'm going to use it again. Or I taste something and it feels off, so I'm not going to use it again. And this is the idea of reinforcement learning. You create a system that's going to try different strategies, and it will receive feedback from the environment. The environment will either gives it awards, or it's going to punish it. And that system will learn how to avoid being punished, like learning how to play a game, for example, and ultimately win that game. Now, there are a lot of tools that exist for supervised learning, for unsupervised learning. Let's just mention some of them, from linear regression to support vector machines to naive Bayes, hidden Markov models, to very simple one, k-nearest neighbors. It's like personally one of my favorites because it's very simple and it shows people that ultimately in machine learning or in classification, it's not magic. It could be as simple as this thing here, which is k-nearest neighbor, and we'll talk about it a little bit in a moment. And then you have neural networks, you have grouping different tools together to provide an answer. In unsupervised learning, tools like k-means clustering, Gaussian mixture models, etc. So a variety of tools that you can apply. Now this is here the nearest neighbor classifier. Classifier meaning it allows us to create a label, to provide a label, classification. It is very simple because what you would say, if I have received, say, some measurements from a machine, and I want to detect if that machine is failing or not, I will just compare those measurements to existing measurements that I had in the past, and then if it's close to measurements where the machine was failing, I will consider that as a failure. If not, I will consider it as normal. This is called nearest neighbor, very simple, but it is going to suffer if you have a lot of training data, meaning a lot of data that you collected already. And in the past, people would use it. You can still use it today if you have like let's say a baby problem to work on with hundreds or thousands of measurements or features or samples. But if you have millions or billions, it's not going to work. And this is where we would need more kind of advanced tools, if you want. And this is where we start introducing what's called deep learning. Now, deep learning is the latest in machine learning, in particular by using artificial neural networks. Now, artificial neural networks are inspired by how we believe that the human brain works. Because in our brains, we have neural networks. We have neurons that are connected together. And our thinking, so the way we think, the way we solve problems, is based on these neurons. And a neuron will be receiving signals from other neurons. It will process those signals and transmit them to other neurons. And this is how we solve problems, we're humans. Now, artificial neural networks is to try to copy this. So you can see these dots here, these circles. These are artificial neurons. The links between them, these are the connections between the neurons. And in artificial neural networks, we try to do what in the human brain is happening. Now, during training, when we say we learn and we're doing training, and we humans also do the same, the more we see examples, like I gave the example of the car and the pickup truck, the more I see examples of cars, the more certain neurons will start to fire together. And the more they fire together, the more their links will become stronger. This is how learning happens, okay? It's how these neurons are connected to each other. Training artificial neural networks on computers is kind of similar. So we try to find the weights, change those weights or the connection, the strength of connection between neurons that will make us produce an output that is desired output, the output that we want given an input. Now, what's the input? The input will be the features, those measurements. Like I gave the example of teaching a child, it could be the image. These are the inputs. The output is what you want it to do. It's a category, it is precipitation level, it is production, etc. Now, machine learning, or at least originally what we did in the past, we worked a lot in this phase here. It's called feature engineering. In feature engineering, you have a human, typically the like the machine learning engineer or the data scientist, who will be starting to look at the data and start thinking, what kind of measurements make sense for me to classify whatever I want to classify or whatever I want to predict. For example, if you are going to predict your sales and you sell ice cream, one of the features that you might want to think of is the temperature outside. So you will think of temperature, and then you might say, oh, if it's raining, probably people wouldn't eat ice cream. So I'm going to take also rain. So this is what you would call feature engineering. It's a pre-selection of those measurements that you are going to do to feed that neural network here in order to make the predictions. Deep learning is actually a neural network, but with more neurons, more layers. Every column here that you see is called a layer. So more layers. And it even can do stuff without or with little interaction from our side for the feature selection or the feature engineering. Because it has so many layers, we can think of it like every layer is going to do some kind of feature selection on its own, and it will feed the other layer those features that will be continuing until solving problems. Now, today, what we use, like for example, Steve will talk about ChatGPT or other large language models, they're all based on deep learning. So neural networks with many layers to extract features and then to other layers that will extract other features until producing the output that is required. So for example, if I'm treating an image like this in here, one layer will be extracting features that could be kind of edges or vertical edges or horizontal edges. And then another one will be dealing with things like textures, like extract textures or represent textures. And then finally, recognize an object, recognize a cat, recognize a human. So every layer is simplifying the problem to the next layer. So deep learning is the way to go today. And why it became so common in around 2010 or so, it's because around 2010, we started to be able to train large systems. I remember the first time I built a neural network, it was in 1998. And in the past, we had like 100 neurons on my neural network. My computer, it was a Pentium computer. It suffered training and 100 neurons neural network. In our brains, we have billions of neurons. And these large deep learning models, they have millions or billions of neurons. So to train them, you need a huge computing power. Okay, so this is why around 2010, these became really the way to go. And as you can see, or probably you are aware of, today, it's all about computing to train such systems. Now, we are not getting into the details here, but know that a neural network that composed of these neurons that are connected together, it can fit any function that you want. You just need to know how to train it. And this is where a lot of work is done on the training, improving the training, etc. Now, if we take just a simple example of how a neural network would work, imagine that we want to recognize or detect or identify the two here. It's handwriting recognition. The input to the neural network will be an image. In an image, we have pixels. So it's rows and columns. Every pixel is just light intensity. So it's a number representing light intensity between 0 and 1. Okay? You feed this into a neural network, and the neural network should produce 2. For example, it should give you the probability that this is a 2 is 0.7. So I recognize that this is a 2. Okay, so our neural network is going to get these features here. So the pixels in this case, in the image, the output is a label. It's 2. So this is a classification we are doing in here. And a neuron on its own is actually very simple. A neuron just adds the signals it receives, applies so these are the inputs that are received. Every signal is having a certain weight. These are the weights that we learn, that we find when we are training a neural network. These are what I mentioned before, how strongly 2 neurons are connected. And then it will add them. It will compare to a bias or add a bias. applies a certain function, activation function, and then boom, produces an output. That output will go to another neuron or other neurons. And this is it. So this is a neural network. Okay? What makes it complicated during training is when you have millions of these neurons. Okay, now just to put us in the context of engineering, machine learning and engineering, I selected two cases that were done at the master's level at EIT by two students, and I was the supervisor of these two projects. And both projects were real-world projects aimed to solve real problems, and they resulted in systems that are actually working and in papers that were published. Okay, so let's take a look at these two cases here. And both are machine learning, so not deep learning, because what you might find actually applicable in engineering, in particular in examples similar to the ones I'm showing here, is that sometimes you don't need a hugely complicated model to provide good results. Sometimes it's a simple neural network with one or two hidden layers, so not very deep, and it will give you very good results. So let's take the first example. In this example, these types of engines here, these are jet engines used in oil and gas industry to produce power. There's one type of failure in these engines. It's called the bleed of valve failure. So a bleed of valve system, it's a system for the anti-surge system or part of the anti-surge system. And if it fails, the engine will still operate. And it's almost impossible to put a sensor there to detect that they fail. You can still run the engine, but then when you have to maintain it, the cost will be very high, and you will be running your engine at low efficiency. So what was the idea? The idea was to pick up whatever sensors data we have already from the engine, because you have already sensors that are available. I'll show you in a moment what were these sensors, and try to analyze the data to predict if there's a failure in the bleed of valve system. Okay, so the types of measurements that were available. So there are things like temperature, like pressure. So you can see here the units in degrees Celsius or in bar or in RPM. Okay, so they are typically temperatures, pressures, RPM, and the power. Okay, available every 3 seconds, we measure that. And the idea was to collect this data and to try to predict if there's a fault in the bleed of valve system or not. The system looks like this. This is a neural network. The inputs here are the features, are those measurements from the sensors. These are neurons, hidden neurons. This is an output neuron that produces an output that is either fault or no fault. Now, the tricky part here, and this is why what I would like to highlight here, is how do we label the data? Because to train a machine learning system, supervised learning, you need to provide it with the features and the label. So we need data where the engine was failing and data where the engine was normal. So what was the trick here? The trick was to look at maintenance log from several years. Each time on the maintenance log, there was a detection that the work done was to repair the bleed of valve system. The data collected before that, few days before that, was labeled automatically as fault. The data after that was labeled automatically as normal because you know that it was repaired. And this is how the data was collected. The system was trained. And then you can see the results here. The yellow is when there was a failure. And the yellow was also when the machine or the algorithm or the machine learning system or the neural network says there's a failure. Actually, it worked like perfectly, detected all past failures, and then it was tested on other engines, and it was like running in parallel to normal control systems to tell maintenance team if there's a failure so that they can schedule a maintenance operation before the failure becomes too costly. So this is an example. I would say it's very simple in this case. A simple neural network was used to solve a very practical problem, and it worked. Another example, it's in steam boilers. Now, what is a steam boiler? A steam boiler, we have water coming in, and there's a source of heat. You boil that water and you produce steam like this. This is the idea. In this thing here that's called the drum, the steam drum, you have the water that's boiling. The level of water in the steam drum should be kept kind of constant. You don't want it to run dry, and you don't want it to overflow. Both are damaging. But there's a problem to control level in a steam drum. One of the issues is that if you start drawing more steam from the drum, pressure will drop. Okay, it's like you're opening a valve, you are releasing steam, pressure will drop inside the drum. When pressure drops, the water level increases because it will expand. Now, if you're using a controller, the controller will see that the level is increasing. What it says, oh, I should be closing the water. There's too much water. But this is actually the opposite it should be doing, because when I draw more steam, I would need more water. So this is one of the issues when controlling the drum level in a steam boiler. Now, these types of systems are used to produce electricity, so in power plants. The idea here was to improve this by trying to predict what will be the level of water in the next few minutes, like around 100, 150 seconds, so that our controller, who is controlling how much water we are going to inject into the boiler, so into the drum, will always be at the right level. What kind of measurements were available? Fuel, total steam flow, feed water flow, and the drum level at every moment. This is the data. Now, what kind of features one can try? And in this project, there are different features were tried, but the two features that really worked very well were current level in the drum and the difference between steam and feed water. So you take, if you want one row here to predict something in the future here. This is the idea. So we take the current situation, steam, feed water, current level, and we want to predict the level in the future. This is a regression. So this is supervised learning, and this is a regression. The previous case we saw is a classification. And simple neural network. Now, different models were tried, including long short-term memory, which is a type of neural network that Steve will be mentioning in a moment for large language models. But interestingly, a simple neural network provided very good results to predict the level in the future. Now, here's another practical thing I would like to highlight. In machine learning, typically, we compare what the machine learning system predicts to the reality. And we say, if it predicts it right, so we have a high correlation between the output of the machine learning system and the reality, we say we have a good system. In applications like these here, where you want the machine learning system to be predicting a dynamic system, predicting what would happen in the future, like in the steam boiler, you want it to be kind of aware of the physics, because this is important. Machine learning systems are not aware of the physics. They know nothing about the mass balance or so, unless you try to teach them so, or try to include it in them. So this is one of the areas where we wanted to test if that machine learning system was actually getting the idea of the mass balance in the steam drum, because if water gets in, steam is getting out. So if you draw more steam than you insert water, you're going to see a level dropping, and the other way around. It's kind of obvious for us, but by training a machine learning system alone, it's not so obvious. So the idea here was to use it as a model. So this block here was created as a model to predict what will be the drum level, and use it with a controller here. This is called a proportional integral derivative controller that will be reading the data coming from the model to decide whether we should be putting more water or less water into the steam drum. And we wanted to see if that system, that the whole simulation will make sense. So let's see what we would get, or what we got. Actually, it made perfect sense. So in the green line, you have the steam. What we have to remember is that the more steam I need, the more water I have to be putting into the drum, because ultimately I'm boiling this water. So you can see when the steam level drops, the blue line, the water level drops. And all of this is based on that machine learning system as a dynamic system for our drum. The level is remaining constant because this is what we want. The orange line is the level. When steam increases, water level increases. So what we have proven here is that that machine learning system, in a sense, it was aware of the physics, which is exactly what we want in things like digital twins, where we want to create a model that is representing a real world system, and we want it to predict correctly so that we can use it to make decisions. So here's just another example where we change the set point. So the green line is the set point, meaning we change how much water we want into the drum. And we can see the blue line, how the water is actually following it. And here in orange, the feed water. So feed water jumps and then starts to stabilize. And finally, we stabilize at a certain level for steam for feed water that will keep the drum level stable and constant. So this is another example in machine learning. And this is it from my side. So I'll leave it back to Steve.
Thanks so much, Heidi. Really appreciate it. Heidi's passionate about learning and AI, and that's a huge amount of work internationally. So thanks, Heidi, and you'll join me as we talk about things, and I'll try and rise to your level of competency, Heidi. And in fact, interesting enough, that steam level of the drum is a classical PID control, and it's very hard, as Heidi says, to use classical PID on its own to solve that problem because the process goes in the opposite way to which you would think. It settles down eventually. So you can use more classical approaches to the control, but you won't get the results you get here. So I don't want to inundate you with technical stuff. I just want to mention a few concepts with the large language models, which are the building further into the AI, the neural networks. And one of the challenges that you have with Heidi's solutions, and maybe Heidi can comment about this later, one of the challenges we have is that if you're doing control of a critical process, like a caustic soda tank or something really, really uber critical, the trick is, how do you know what is in this black box? And that is a major, major problem with any neural network. How do you know what's going on in the box? Because you can't identify where the data is. And that's a big challenge. And maybe, Heidi, that's a trick question for you to answer a bit later. How do you deal with the black box problem for critical processes? But I'll come back to you that bit later. So the transformer is the model used, and essentially, without going into enormous detail on this, it's actually a really fascinating process because you can actually create your own transformers with Python if you're a Python aficionado, and you don't need to be a guru today because you can use a lot of AI to help you write the programs. But effectively, the first thing you do is that every word that is trained on training your AI tools, whether it's ChatGPT or one of the others, you actually tokenize every bit of information and you create a digital pattern of it. So you actually have it in a space, in a digital space. In other words, you have 1,000 dimensions, and then you have 1,000 bits of information for a particular word, and you then try and create a representation. And that's why you sometimes see the comment that these AI tools, for all the gigabytes, thousands of gigabytes of books and things they've absorbed, they've never actually understood one word because it's all digitized, and it's digitized into a format which they can then work with. And then once they've done that, you would use these transformer models to actually make it into a useful thing. And one of the breakthroughs was the transformer model. And that's where you have this attention function. And the idea is that you've got a stream of words that you're trained on, and when you write a sentence, a prompt out, what is the model, transformer model will then predict the next word. And you're familiar with this. You do it all day with your phones. You predict the next word. And
Annoying. Steve.
very annoying, absolutely right. So that's the challenge. And of course, the question is, what word does it select? And that is the basic of the transformer model. And then the next part of the transformer model is to put the words in context. Because every word in English has a meaning, but of course, it only has a real meaning in the sentence. And not only in the sentence, in the paragraph, in the book. And that has to be picked up and used. So that is a big challenge. So this is where the attention transformer model works. And as I said, there's encoders. And I'm not going to go into this in detail here because we've got a shortage of time. We're going to focus on the main stuff. Self-attention. And let's keep going.
Just remember you're getting these slides,
Yeah.
everyone.
So the transformer model is obviously the building block. And oddly enough, there hasn't been too much change from the transformer model as one of the key drivers, even though it's now 6-7 years later. Now, obviously, one of the programs that we use is ChatGPT or Claude or Llama. And one of the techniques uses prompt engineering, which I'm sure everyone here has used at some time or another. And there's obviously a few issues which we want to talk about. So I'm going to now spend a bit of time talking about the prompting, and then we're going to move on to the case study. So the methodology is there. So we're just going to ask you a few questions about your skills and your background with AI before we launch into that. So everyone online, if you don't mind, we're going to go to a few more questions to ask you before we set the context for the next part of the presentation.
Fantastic. Back to the AHA slide. So again, we'll go to the next question. You may need to just refresh your page, or you can just again scan the QR code again. But you should all have access to the next question. So yeah.
Just impress on them the 3 max words, James.
Yeah. So just please, I'm just trying to remember what options. I think you only get 3 fields to add to answer the question. So you can only add 3. That's the maximum allowed.
And by the way, we're not online or in here, we're not trying to promote we haven't got any insurance or teaching to promote you. These are purely questions to set the stage for the next part of this presentation, which is where we look at the ChatGPT or Gemini. So what is your most important engineering skill? Communication, ability to learn, knowledge. Yep. Tenacity. Yep, that's a good one. Ability to learn. Designing. Tech skills. Creative thinking. Yep. Measurement. Yeah, so we've got some really good ones there. Interesting enough, no particular skills with wiring rules or ability to learn, adaptability, research, reflection, creative thinking. Yep, already been through that. Okay, good. Patience is a good one there.
Can I just pause there quickly? Because the food has been out for a while, everybody, the EIT would like to take it back to the kitchens. So go berserk quickly.
Just help yourself to the food while we carry on talking. If you're hungry.
Tea and coffee and the juices will stay there and the water.
Yeah, so please help yourself while we continue.
It's really good.
Yeah.
Oh, delicious. These are very nice as well. It's like sandwiches.
Okay, so most important skill, everyone online, we've got
Korean sandwiches
Like a
here.
little bit of
solving,
Some veggies.
Spencer still typing.
Do you need to taste this, Tom?
Yes, please.
Which one?
Always have to be through.
Oh,
Salmon.
This is tuna.
Vegetarian.
There's veggie over there.
I'll just bring that
And
around.
those little pink wraps up.
The pink.
You guys want to grab some?
Delicious.
They're going.
Oh, the salmon. Yeah, I had one of those. Yeah, very good. Thank you.
That's salmon. I think that one's tuna.
Tuna.
No, I don't.
Okay, next question 5.
I have a tuna one. Sorry, Caroline, she's got the plate.
See, the questions all very
I don't even.
critical thinking, creativity. What AI tool do you use? Be interesting to know what AI tool you use. Most will probably say ChatGPT. Okay.
Oh, sorry.
Do you use an AI tool? Yes or no? Always interesting. That's one. Let's say, do you use ChatGPT or an AI tool? Probably would have been good to get the nuances, but I think most of us are busy using a tool. And obviously there's a range of tools available. And in fact, even in Facebook, you've got Llama, and they are being pushed into your face all the time. Okay, what AI tool? Let's look at question 6. System uses. Do you find AI useful or not? Is it a waste of time? Has it been useful? Okay, yeah, there we go. So everyone's fairly happy with it. That's good. We've had about 2 years ago when we asked that question, we had lots of people very unhappy, but perhaps the tools are becoming a bit more mature and expectations have moderated, I suspect. So that's good. Okay, excellent. Okay, next one. And this is a really interesting one, which will really shadow what we're going to talk about now is what applications do you have for AI? What do you use it for? Just put down, I think it's free form, so you can write down there. Do you use it for summarizing stuff? Do you use it for design? If you're using it for design, it'll be interesting to know what design you're using. I was talking to a guy last week who was using it for electrical design and designing switchboards, which I found quite interesting. It's quite a wide-ranging group of stuff, actually. Researching, finding information, helping you write documents, researching, studying, conducting research, checking my grammar. Yep, that's a good one. I use it for coding. Okay, there you go. Coding, solid engineering application. Okay, so we've got a pretty good breakdown there. Research, report writing, looking for information. And honestly, in my personal opinion, at the moment today, on the 4th of July, I honestly feel very effective when I use AI as a super duper search engine. So it gives me a bit more. And obviously, this is indicated, yeah, a lot of people using it for a thing. But interesting enough, there's no examples apart from design optimization of systems, not many examples of using it for engineering, a specific engineering design. But obviously, most of the time it's a research tool, which is good. And I think it will change over the next year or two. They'll be using more design of systems, which is what we're going to do with our case study now. Research. Okay, good. Thanks. There's nothing much else there.
If you can share the slides again, thank you.
So obviously, people are a bit cautious about using it for engineering design group and online. We've got 50 odd people. Maybe we can ask Hardy, do you use it for any design? Are you using AI for any design?
Absolutely. You use it for design. I use it also to find some weaknesses in any design or any thinking process, and use it a lot for coding.
Brilliant. Thanks so much, Heidi. So, there are people out there using it for design and acting as a devil's advocate for a particular design you've used. Okay. Right. So and I suppose that summarizes what everyone's put on the thing there. I always hope that someone will come up with some amazing use of it, but certainly summarizing text and it's trained on books and stuff like that. And obviously, for those of you not familiar with it, but I think most people are familiar here, you've got to have a prompt formula. And prompts, by the way, are becoming less and less important, according to the OpenAI guys and ladies. But this is the typical thing. Put in, you are a process control engineer, and I want you to work out the PID constants for this bit of data, which I'm going to provide you with. And unfortunately, please do not go beyond a flow rate of 100 cubic meters per hour on this flow design. So what you do is put them in there. And then if you want to, and it's happening now with most systems, they do recursion. Can anyone tell me what recursion means? Why would you ask for recursion? Anyone online? Can you see any chats there? Chats? Hello, anyone online? What's recursion mean? Well, essentially what you want to do, which is perhaps a little bit difficult, you want to get into the mind of the beast and say, you have told me that you want to do this design, give me step by step your thinking. And often that unnerves you, because when you look at it, you say, no, that's completely wrong. You've made the wrong assumptions. So recursion is useful. And you'll see it flickering around now on the ChatGPT, and a lot of them, they're telling you what they're looking for information. And I'm going onto this site and I'm looking at that. So that's really important to get a feel, as we had on that wretched Air India flight, you want to have a black box of what's gone on. Where has the decisions come from? Because that is a big problem. And then obviously be detailed, specific, and providing examples, and obviously put boundaries in. What do you want ChatGPT not to do, or Gemini not to do? Do not do this, do this. So, and obviously when you put your wonderful, Hardy Hart puts his wonderful Woodside data in the analysis, you may find that it's now snapped up by the AI animals, and of course they'll use that for future use. So there's a big question mark there. How do you handle the plant data story? How do you keep it under control so you don't release it to the world of the boys in Beijing and Moscow?
Well, typically it's by testing, because if you just look at the coefficients inside the neural network, it's completely like useless for us. But it's typically by testing and by, as you mentioned, like creating boundaries and try to see how the system would respond to specific actions where you know what you wanted to produce as an output. And in the example of the boiler, it was this exact test. Like we wanted to see if the machine learning system actually understood the physics of the system or not. Like if I feed more water and I take less steam, is it going to say that the level will increase or not? Because it might hallucinate and give you like completely different results. So I would say it's still by testing cases that you know it should provide a certain type of output.
Thanks, Heidi. So Heidi was answering my previous question, which is the black box problem. The animal that you're dealing with, the AI animal you're dealing with, how do you know what's going on? As Heidi says, lots of testing, and keep it within those boundaries. If you go outside the boundaries, all bets are off. So if your conveyor belt is running at 0 to 100 tons per hour and you start operating at 150 tons per hour, you could be in the poo. So obviously watch out for that. But sorry about that. I apologize online. Heidi, the question I have is, when I put all this data in my wonderful ChatGPT to do the analysis, and it's proprietary data, how do I protect that?
That's absolutely difficult. I'm not sure that there's a solution to that for the moment. Very difficult.
Yeah. So thanks, Heidi, for your honesty. I do appreciate that. Okay, so that's obviously a big challenge. And recursion we've just spoken about, so we won't go into that. And I won't go into this. These are a few examples online with use of it. And then obviously you are always critical. Don't trust anything coming out of it until you've tested it, and you need to be checking. And as my chum Philippe, my AI bot, told me, it's called AI assisted human in command. So the AI chum is your friend. Do not trust it 1 inch. And I think many of you have already come across that. And here's a sort of typical example of engineering professionals. I'm just going to give a few examples before we launch into the case study. Answering technical questions. So this goes beyond just the research. One area which everyone talks about is it reproduces code perfectly, and that's why there's been a huge collapse in programmers, demand for programmers, and I suspect that's one of the reasons why Microsoft and all these large companies are letting people go, because they can do it more efficiently. And I've had friends here in London who suddenly had 4 programmers working for him, and then suddenly none, and then suddenly he was looking for a job opportunity. So it has an impact. And of course, one of the great things which I've worked on extensively is programmable logic controllers, Adam Bradley or Siemens, and you can actually generate great ladder logic code quite easily with the GPT coding interpreter. So again, check, because you can't trust them. And then other opportunities are timelines, budgeting. Again, when you do budgeting, make sure you check the assumptions. Often you're horrified by the assumptions the ChatGPT animal makes. They're completely wrong or out. So be very careful there. And obviously, latest research, which everyone is talking.
I'll make a quick comment. There's a whole new term that's been created, and I think a few of you may be familiar with it. It's called vibe coding, which is essentially AI that's developed using AI to actually develop your code without being a programmer yourself, which is not exactly reliable yet, but it's quite impressive what's coming out.
No, thanks, James. Yeah, certainly it's happening big time. And then I've got suggestions here about using ChatGPT when teaching. Again, I won't go into this here because I want to go to the case study as soon as possible. But there's a really good bunch of educators in Pennsylvania called Ethan Mollick and his wife Lila Mollick, doing some amazing stuff with teaching and AI, and they're worth getting onto their newsletters. They have some really good stuff with teaching. I'm not going to go through that. And there's a few suggestions here. I've just repeated some suggestions here from Business Insider and Wall Street Journal on things to look for when you're putting together your prompts, fine-tune prompts. It's a big discussion. Avoid long prompts, and obviously rephrase. And I suppose another thing to do is get the model to critique its own output. That's also, or use another AI tool to critique output if you're concerned about the quality. You may be horrified or surprised, or pleasantly surprised. Okay. And the Wall Street Journal has another little challenge here. And that's a big problem that we have today. And that is you've got a huge choice of AI tools. And of course, you will think about the tools that you've got. And for example, if you use ChatGPT, you will have a few tools to choose from. And obviously the one tool they say to you, I'm not sure how one can believe it, maybe Heidi will comment about that. But when you choose the tools, if you've got a detailed, in-depth research analysis, you can use the Cloud for Heavy Reasoning, 4.5, but you may find your data released to the world. If you use the smaller tool, you may then be fairly assured that that data is not going to be released to the world, but then you may have some issues with the level of reasoning. I don't know, Heidi, what your tool, your model selection is like. What's your strategy there? Which AI model to use? Which one do you prefer?
As you've mentioned it. Personally, I like ChatGPT. I like also DeepSeek, especially if you want to run it locally on your own computer. So there are things that I would prefer to completely protect. In this case, I would like to run it on my own system. So DeepSeek is great for this because it's open source, and ChatGPT is like the way to go.
Thanks, Heidi. And presumably you haven't asked DeepSeek about Tiananmen Square. Sorry, it's just one of my sick jokes. Basically, be aware, one of the challenges with all these tools, which I'll come to in a tick, they all have biases. So be aware of that. And it's unfortunate that the Northern Hemisphere dominates the bias game. The Southern Hemisphere is the recipient. So there's some issues that one's got to be really careful about when you ask certain questions.
Why do you say pretend it is sentient? Why?
Sorry? Biases.
Why do you pretend it is sentient?
Oh, it's just my deranged sense of humor, I suppose. So they talk about whether you should treat it as a friend or not. I suppose you trust it a lot, so you ask good questions, but I suppose at the end of the day, you've got to realize you're on your own.
It makes it easier to conceptualize how it works.
Yeah.
You treat it as a sentient. Although it's not.
And guardrails are necessary, as Heidi says. You've got to, obviously, when you ask questions, when you set up a ChatGPT model, you've got to make sure it operates within certain parameters. So James has got a little demo there. I know time is tight, James, but maybe can you show the little tool in a few minutes? So we've got a little tool which we developed for one of our basic courses on engineering. And it's actually quite interesting how it interacts. And James, just 1 or 2 minutes before I go into the case study, we want to squeeze a case study. It'll only be 2 minutes. And then we've got a case study for everyone online and here in the room. So,
Okay.
we run a quick AI tool, which is a teaching tool.
Can everyone online see my screen?
Yes,
I'm not
James,
sure.
thanks.
You can? Fantastic. Okay, cool. So yeah, EIT, which is a partner company of ECT, has developed an online course. We're with existing materials. So we're just sort of playing around with AI, trying to get our head around how it could be incorporated into our learning effectively. I don't know why it's not showing on the screen. Just try and move it. So essentially, what we try to do is we try to create a completely self-paced course where a chatbot will assist and ask questions and try and work through the content with the actual learner itself. So, for example, if we go to one of our existing videos on the course, I'll quickly run right to the end of it. So what we've done is we've incorporated, based on the actual video itself, the idea is that the AI can sort of be there as a little bit of a virtual tutor. So if I open the chatbot, which we've called Eva, it's very aware of sort of what the video is and what the content is. So I can actually ask it some questions.
There's a course on power systems, basic power systems, which every engineer has probably done sometime.
Yeah.
Mechanical, civil, electrical.
So what we've essentially done, so what it will do is it will pretty much, you can just ask any questions you want about it, about the actual video, provides a summary. And the idea again is it doesn't just give you the actual answers as well. It tries to work with you, tries to help you learn as you go through the content. So I'll just try and skip right to the end. So just turn the sound down a bit. So if I answer completely wrong, say wattage. What it doesn't do is it doesn't just give you the answer, it actually tries to work through it with you, tries to sort of lead you to the right, to the actual correct answers. Anyway, I'll just mute that. That's kind of what we're trying to do. We're trying to see how we can make it more effective. But this is the one test course that we have currently live, and we are looking to improve it and develop it to make it sort of really as interactive and actually useful as possible. The key thing we're trying to avoid is this just being another annoying chatbot. We want this to be very effective and useful for the learners themselves.
Yeah, I mean, it can be very frustrating dealing with, if you go onto the bank site, it drives me into a frenzy when you're on one of those chatbots trying to get some support, as you probably have experienced yourself. So we want it to be a really good support to the instructor, enabling the instructor to focus more on the students and issues that come out there. So I think it's got a lot of opportunity there. So we'll...
Yeah, Barry, sorry, if you can share the slides again.
Sorry, Barry, yeah, go back. So we've got some way to go there. Now, okay, so what we want to do now is look at section 8. We've got a few case studies here. So obviously I'm aware that time is tight, but you all have got some AI tool on your phones, hopefully, and we'd like to break up into groups. I know it's a bit late in the, as you've got it here. So what we want you to do is to, it's getting late, but we can still squeeze this in. So what we want to do is, we've got a few case studies, and I want you to, we'll get each group here to spend 5 or 6 minutes talking amongst themselves the solution to this. And then if you could just nominate a leader, just to give us a quick 1 or 2 minute dissertation of what you've learned. And online, we'd like you to do the same. We'll give you one of the activities to do. And if you can take a picture of the activity, so it's on your phone, we'll show it up here now. Otherwise, we've got to flick backwards and forth. So online, if you can take a picture of the case studies, we'll run through, we'll take one at a time. So really, you're going to use your AI tool. Normally, this exercise could take an hour or 2. We're trying to do it in 5, 8 minutes, but matter, you'll get the idea. And then, unfortunately, at the end, I'll show you the issues that come up as you come up with your solutions. But some of the things you need to consider. So let's go through the thing. So you should all have an AI tool.
You don't have to use that one. That was just a free one. Use whatever AI tool you want.
Yeah, that's a free one. But so the first one is water resources engineering. So you may all be electrical and say, no, I don't want to do that. But we're going to nominate you guys here to do the water resources engineering project. You're a top water resources civil engineer. Ask ChatGPT or whatever tool you want to use to help you with the following design problem. A borehole and water treatment plant in a remote part of the UK. My favourite spot is Kinlochbervie in northern Scotland. And for the provision of clean water for a community of 300 people. Select a specific location, Wales, Meekatharra in Western Australia. Consider the specifics and constraints of the project in formulating design. Critically assess the response from ChatGPT. Make some suggestions. So take a photograph of that and ask some design questions to go about the project, and then nominate someone here to lead the team. Let's ask our friend here in the front. You're now going to be the leader. And do you mind coordinating the group? Sorry about that. Okay, so the next one, or we can go somewhere else if you don't feel comfortable. Okay, next one, bridge construction engineering. You are a top bridge construction engineer. ChatGPT to help. You've got a bridge across a river 30 meters wide for a remote community in Scotland using local materials. Select a location. I've selected Kinlochbervie. It's my favorite spot. And consider the specifics and the constraints of the project when formulating design. Critically assess the response from ChatGPT. Make some suggestions for the design of the picture of the works that you have created. So forget about the last one. We can do the design layout. We're not going to do that here with pictures. That's a journey too far in the time available. So just do.
As long as one of you have taken a photograph of that, because obviously the next slide.
Take a picture of that and do the best you can.
This one, I think.
Okay, and online, please, everyone there, grab one of these that you want to, and then we'll look. You can put in the chat. You can put in the chat your suggestions, solutions. The next one is a solar energy project at the back there. You're a top solar power designer. Ask ChatGPT to help you with the following design problem. A solar panel installation of 30 kilowatts for a building 2 floors
Take
high
your hand away, Steve, so they can
with
vote.
roof panels. Select one of the 2 locations, Stevenage, Hertfordshire, or Western Australia, or one of 3 locations. Fix that next time. And consider the specifics and constraints and critically assess the response from ChatGPT. That's the group at the back. And then for those online who want to do the 4th one, let's go to the 4th one, road building project. You're a top road construction engineer.
Probably not a good
Careers in
I'm not
the
an
flat
engineer,
road
so I'm
in the
probably
Cedarburg
best one
region.
would be-
I think
Consider the specifics, assess the response. So if you don't mind,
Engineer.
consider those 4 and give us some of your responses.
think outside the box, Joe, you
7 minutes. Tea and whatever.
This could be a very unusual one
It's a very fast design. It's a uber fast design.
because they're all contributions.
Heidi, I don't know if you've got any comments about the design process.
So, yeah, so if you're sorry,
Send them to
briefly,
the end of the presentation in 5 minutes. 10 minutes.
help you with the following design problem.
2 minutes and then we'll
Some teachers use
we will summarize everyone's comments. Don't worry too much.
using the report.
We can't expect you to solve the world's
Like 5
problems
hours,
in
about an
5
hour.
minutes.
Yeah. So yeah,
We just want to get a bit of a feeling for your feedback.
Yeah.
So.
yeah.
Sound like.
And online, if you can text in on the chat your commentary. So just text in on the chat, save it into a Word file, and just put it into the text. We can see your comments as well. And I don't know, Barry, if there's any comments from people. Barry?
No, there's no one yet.
No comments.
We
So-
requested for it.
Can you explain how we put? I don't know how to add the comments in. Basically.
No, don't worry. No, absolutely. No, we're not that clever. That's a very good question. In fact, we'll make an improvement for next time. I must say, in previous times, we've had computers, but we've made it simpler now. So you will just tell us what your feedback is and your comments. So, okay, so let's start with our first, the A team here.
Try and give me at least one.
Yeah, A team with their comments.
Just
It can be
more minutes.
1 more minute.
It's just time.
And please give us any comments online if you have any comments.
Yeah. Just let me kind of go back to the slides.
I got
Yeah.
process.
So we have. I thought that was best.
Process.
Yeah.
With 5 steps, and then there was a summary table.
The 5 steps of.
5
And
steps
actually,
for
actually 49 minutes.
going from
Yeah, maybe.
planning permission, like all the steps that you would need to
Please
do.
may I ask anyone online if you can put your answers on the chat bubble,
Yeah,
That-
regulation way to installation.
stick it in there and let's see what.
That's fine.
My name's Laura.
Okay, brilliant.
No
Super.
problem. Thank you.
Yeah. And your.
Okay, thank you very much. Thanks, Justine. Thank you very much. We'll take a few samples of those. Justine, thank you. We'll take a few of those examples.
Meeting cost of.
And
Is that Stephen?
let's go to the first one.
Okay. Including VAT. Very good.
One.
Okay, we'll set the slide. Okay, great. Gentlemen, what's your name, please?
Just trying to get.
Daniel.
Daniel.
Yeah.
Okay. In the lion's den, I'm afraid.
Oh no, do you know what? It's fine. Like no drama. He's made some suggestions in terms of types of panel to use.
Okay.
Use it for everything. Sit round.
Useful.
Yeah, absolutely.
Where else are you getting this information from? And
Did you give any practical?
it does high efficiency.
Be handy to be able to stick it in big man.
I'm not going to even.
Very-
I'm certainly not going to spell it.
Or any ones to stay away from like low efficiency?
Yeah, so high efficiency, 450 to 500.
So asking, would you like it?
It's basically 21 to 23% efficiency. You lose, I know this, you lose a lot of solar energy through heat.
Okay, let's go for the water resource engineering project. I said, don't fuss
Yeah.
too much.
21
This
to
is just to
23%
give you a
efficiency.
feeling for what the solutions are, and
Fine.
I want to go through some of the challenges that you will face and some of the issues. So we're trying to be very simplistic here, so please forgive us, but it's useful.
Okay.
Yeah.
So let's start with the first group. What's your outcomes?
You're already engineers?
If you can stand up and tell us your name.
So even if you're like Diana, Diana.
Fabiana, sorry, I should remember. Fabiana, and you can just stand up and tell the other groups.
It's also
Oh, yeah.
Okay.
You can help perhaps.
Okay.
Yeah, so,
Just give me one, please.
Maybe,
And
could you stand up and give us your,
Would you-
what's your
Nice.
Fabiana or?
Yeah.
yeah, you can just introduce what of it is.
So-
Usually prime permission.
Just stand over there, just so everyone can hear you, that's all. Thanks, Fabiana. Fabiana and, sorry, what's your name, sir?
Nicholas.
Nicholas. So Fabiana and Nicholas are going to do a quick 2-minute presentation on their design. As I said, it's very ad hoc, very quick, but it just shows you the power and the weaknesses of the tools.
So the introduction is gonna make him. It's like the solar powered.
So our design is about a solar powered bore system, the water treatment plant, based on a location in Zimbabwe, where I actually come from, in a city called Chitumbiza.
Good, brilliant.
So the population that we're gonna try to help is 300 people. It's a small community. And the climate is dry seasons and subtropical. So the water challenges are groundwater, the main issue. So the recommended treatment change is pre-filtration. And you can keep going with the rest of it. It's UV ester lasers to like
UV, yep.
yeah.
To for
It also
get rid of all the germs, bugs.
Okay, and partly we looked at just funding for the project. Wouldn't really rely on the government, and materials needed for the project will have to be imported. Skills available locally for the construction and development of the project. And we use ground tanks for storage of the water.
And that's from ChatGPT, was it?
well, yeah.
That's good. Okay, some of it comes from ChatGPT. That's good. Okay, that's excellent. Thank you very much. Please go on. Obviously, as you pointed out in the questions we asked, it's very good for research. There's no doubt about it. So this team didn't quite get into the actual design stuff, but they started putting all the questions together, which is brilliant. That's exactly what you'll find ChatGPT really, really helpful. And it's a low risk way of starting. Ask the questions, get some ideas. But as you can see, they were starting to use terms which you probably need to be an expert in to try and assess whether ChatGPT is doing the right thing or not. Anyway, let's move on to the next
Can I
group.
just quickly ask, do you think it was useful, particularly if you're from the area? Do you think it was making sense to ChatGPT?
Yeah, from even from the solution that ChatGPT provided, we didn't really get into the technical of it, yeah, but we had a brief look at it. Yes, it was much sense.
A lot of information.
Actually, yeah.
Yeah, there's a lot.
A lot of information, yeah. And on the phone, I'm sorry about the phone.
But it said something about needing to get the resources in to the country. Did you think that was accurate?
Brainstormed that. But
Yeah, I think that part.
We didn't have really.
But that's brilliant because you were the experts as well.
It's actually said that, didn't it?
No,
I don't know.
Okay, that's good. Okay, let's try the bridge construction project. Sorry, what's your name, sir? Chris. So Chris is our guru here. Thanks, Chris.
So we looked at the feasibility study of creating a bridge in Scotland, and ChatGPT looked at the terrain, the glacial tilt, sand, gravel and peat deposits, the landscape, rugged coastline, the moorlands. We looked at variable ground conditions, geotechnical surveys. That is. It also looked at flood risks. It gave us information on tidal variation. So estimates on tidal variations, flood risks in general. It gave us information on the local workforce, the population, materials we could use within the local vicinity, stuff that would needed to be imported. We looked at it gave information on the infrastructure for the region to build it, looking at roads, utilities, water supply, hydroelectric plants and the power outputs. The harbour information on the ports. It talked about costing, budgeting, additional works, drainage, total project estimation cost of 1.3 to 4.5 million. Variables in ground conditions, food protection, design complexity, and then obviously gave information about project timelines, construction phases. It went on and on and on. It gave information on community authorities, on local community council engagements and local covenants within the area, legal requirements, climate impact. And then it asked, would we like to produce that all in a PowerPoint?
Thanks very much, Chris. Much, Steve. That's really interesting. That's quite useful, and as you can see, it's quite pretty strong. So it's sourced all that data from from documents and stuff, and that's really very encouraging. Obviously, once you start drilling into the actual serious design stuff, you probably need an expert to look at it. But it's a good sounding board to start looking at what you need. Thanks very much, Chris and the happy team there. The next one, solar energy panel design. Top solar panel designer. Yep.
Yeah.
And your name is?
Yeah, Joe.
Joe. Thanks, Joe, for standing up and holding forth.
Yeah, well, really good team effort from Laura, Joseph, we've got Joseph as well as a Joe, and Daniel coming into the Lion's Den today, and Steve.
Lion's Den.
Yeah, well, so we had the kind of none of our table at the start of the 8 minutes were engineers, but obviously by the end of the 8 minutes we'd already educated ourselves, as well as looking to kind of solve the problem. I'm not trying to disparage the engineering profession. You need a lot of training to be a good engineer, but yeah, you know where I'm coming from.
If anyone needs any work doing, we'll put out some quotes. Yeah.
Yeah. Appropriately costed. Yeah. So anyway,
Not everyone.
So the first thing we looked at, because there was various destinations, possible locations. I'm trying to find my notes. Yeah, why Stevenage would be a good location for a 30 kilowatt solar panel installation on a 2-story building with roof panels. And we actually had 2 other destinations to look at, one in Western Australia and one in South Africa. And obviously, after an exhaustive pros and cons of each one, we went with Stevenage, including for the reasoning that ChatGPT provided, that Stevenage would provide. It assures us south-facing roofs, government incentives and support, urban infrastructure, and having come through the train station today, I know that the urban infrastructure exists there, local support and planning conditions, roof panel suitability, and long-term investment value. And Laura did some particular research in terms of in the Stevenage area, there would be a thorough process and various steps of planning permission, including from the building onwards to the installation process. 5 key steps, I think you found out, Laura, there. Thank you for that. Joseph also looked into the cost of this building, 2-story building with roof panels, and with ChatGPT estimated it will be about £33,000, exclusive of that. Okay. And then going back to Daniel, he looked intensively at the types of panels to use, and I think we're looking at ones around about 450, 500 watts, and we're obviously very mindful that you can lose a lot of energy through heat. And Steve clarified the power requirement, and actually in our expert opinion, after the 8 minutes, we believe that 30 kilowatts is very small in terms of power requirement. But yeah, that's basically what we got up to. But we also saw the need for more professional engineering input into the project, and linked into that, Laura also found out the various websites that we could make use of, including the highly regarded from ChatGPT, stevenage.gov.uk.
That's marvelous. That's incredible. And you can obviously critique engineers' designs now. Someone sends a design to you, you can say, let's make sense of this. Is he overcharging or she overcharging us or whatever? So we've got one suggestion. We had one suggestion before from Justine Gumbangan. Thank you very much, Justine. Really appreciate your efforts. So this is the water intake, and she's put down some suggestions there: flow meter, pressure transmitter, discharge pipe to thing. Obviously, it's a bit of a challenge trying to fit it all in, but thanks, Justine. But you can see that ChatGPT is obviously putting down some sensible stuff for instrumentation and control. And then we've got Onyeka Ilu. Thank you very much, Onyeka. I'm sorry if I'm mispronouncing your name, but a road building project, and obviously the environmental impact assessment is critical. and this is from one of our online attendees of the 50 odd. Every terrain has got its challenges, full assessment to get the contract anticipate. So you can see there's a lot of support within the ChatGPT. And I just want to look at some of the issues before we call it quits tonight. If you can just go to the design pitfalls. So these are some of the pitfalls you need to think about. And I'm going to ask Heidi Haag. Heidi, you still there? I'm sorry, it's well after your siesta time in Spain today. I apologize for that. But here's some of the AI design pitfalls you need to think about when you use these tools. Obviously, the first thing is, as Heidi said earlier on, hallucinations. You may get complete gibberish, and it often happens. So be aware of that. But one of the more insidious ones is, unfortunately, missing local codes. You won't get necessary good, up-to-date information for local standards, which you do need in an engineering design. So, for example, there will be snippets of those codes floating around in the freeware online, but the detailed, up-to-date codes may not be there. So that's a challenge. So you've got to be really vigilant about that. Check it. Ask ChatGPT, do you have the IEC 61850 substation design code for 1992 or 2025 or whatever? Often the sites that you go to, there's no site data. It's not on the internet because no one's done that particular work there. They've done all the work here in Stevenage, and there's probably plenty of data here, but in remote sites, you may not find it. So watch out for that. Other issues are, and it's more a problem for the unfortunate Southern Hemisphere, often most of the stuff is very American-centric. So designs and approaches will follow Northern Hemisphere. So you've got to be really vigilant about the biases there, because it is a major bias. Other issues for you as an engineer, even if you use ChatGPT or whatever to do the design, the problems when the design fails is yours, no one else's, as the engineer. And then there's also this very interesting thing. You spend millions of dollars doing all the design work, ChatGPT and yourselves and all your experts, and as soon as you put it online, who owns it? Do you own it? Does your client own it? Question. So you may be in a very awkward area there. So watch out for that. Big problem. And obviously, the other issue is de-skilling of junior staff. And in fact, the whole thing about AI, I would just like to comment about. We've got a lovely lady from, I know, strangely, from North Dakota, Barbara, who has a top online course in the world. It's got millions and millions of people. It's on learning skills. And she's done some really great research recently, and she's found unequivocally the use of these tools without you training your own brain means that your brain rots. So you've got to keep pushing the envelope with your learning as well. Otherwise, you will lose out. And I don't know, Uncle Heidi, Dr. Heidi, how you handle it, but that's a big challenge. And then finally, you've got to keep looking at skill gaps and etc. So it is a great chum to use, but it's very limited today. Whether that'll change, I'm not sure, but it's useful. It's not unuseful, but be aware of those challenges. Dr. Heidi Haag, the last blow from you, last comment from you, what can you tell us? Anything of use?
I just want to highlight exactly what you've mentioned is like, we should not outsource the real thinking part to the AI because our brain will shrink. And there are studies actually that they prove that. We should use AI to help us even think more and consider it like, ask it to find weaknesses in our argument so that we can improve, instead of just outsourcing the thinking to it. So this is like my piece of advice. Thank you.
Thanks very much, Heidi. Really appreciate that. Thank you so much for your contribution to today. all the way from Spain, and look forward to talking again. So, yeah, so certainly there are some challenges, but there's also some huge opportunities with AI. And I encourage you to keep experimenting and look at the slides, send me comments, any other things. So no, don't worry, there's a whole thing on graphics and design there, which I won't go into today. We often do graphic design. So in section 9, wrap up, any comments from anyone here? Any comments online? Anyone online? Any comments before you break for the weekend?
So questions, hey?
Questions, comments, whatever. Any comments here?
Do you know if there's any changes to intellectual property laws around AI?
Okay, so that's a very good question. And one of the slides here, which I didn't go into, is the fact that the materials that these AI tools have gathered is often stolen from textbooks and stuff like that. So the question is, who owns it? Is there fair right of use? There was a court case decided a few weeks ago where, and Heidi, you may have some comments on the fair use. There was a court case a few weeks ago in New York where they did allow, in a very limited way, fair right of use. So you could use the materials. But the big publishers are waiting for their cases to be heard, and there may be issues there. And I may ask Heidi or Carolina if you have any comments on that.
Yeah, actually, part of my research, I'm looking into AI can be creative. And I've actually spoken to an artist, and he made a really interesting comment, which was about AI can't fundamentally be creative because it can't be inspired, it can't have that feeling, which is very human. And he also described the process of creativity as something that is about the journey, and AI is all about the results. So you ask it a question, it gives you, while, when you're being creative, it's about you're painting, it's about the whole process of painting rather than getting to having a painting.
That's true. That's a very good point. Thanks.
Yeah, and to answer his question, there is a lot of background talk about that. So specifically, what if AI is taking all this data? Who's owning the data essentially? I think one of the problems, and Steve mentioned this, was about AI is very north-centric, essentially. So what happens is then you have all these governments coming together to try and create laws, but then how can you really create laws to cover the whole world? So you have to go market by market, but then it kind of defeats the point of having this massive technology kind of taking over. So very nuanced and very complicated to give a great answer.
Thanks, Carolina. So certainly it's a very moving piece, but as I said, the court did allow in limited cases fair right of use, which means you can use the materials. But I would say that it's a very developing space. Heidi, do you have any comments about AI fair usage or not?
Just that it's really difficult actually to prove that AI has used some source from its output. So it simply adds to the complexity of the thing. And at the same time, if governments will start limit AI models to be trained on existing data, the whole benefits of AI will simply shrink. So it's a balance to be found.
Thanks so much, Heidi. Yeah, it's a very good question. Yep.
Yeah, thank you. Just two quick points from me, and one builds on what has just been said there about the research, which is very interesting. My background the last 6-7 years is data protection, and I've also done various AI governance professional certifications. And it's interesting in terms of generally you get artificial intelligence pulling in one direction and personal data protection pulling in another. In terms of if you like, AI companies, generally AI developers, very focused on we need more data, and the more data we have, the more accurate will be the models, and so on and so forth. Whereas data protection, since GDPR came in 2018, etc., one of the principles of that is data minimization. Only use the personal data you need for that particular purpose. And you don't use excessive data like you're signing up for a gym membership. Do you really need to give your phone number, your email address, your home phone number, and so on and so forth? So I think there's that kind of interesting balance to be had between what AI developers, AI systems want, and also, and it comes out in your slides, the personal data protection aspects. And the second thing I just mentioned at our table, I'm a governor of 2 schools in North London, and we're starting to use in our 2 schools artificial intelligence, and it has real benefits in terms of, I was at the trust board meeting last night, one of our teachers has found that she's able, rather than spending 5 hours putting together a report with AI tools, it's down to about an hour, which is really good and a tangible benefit. But it worries me in terms of, just going back to the point made in the last 5 or 10 minutes, about the need for students are using AI a lot, not just our schools, but other schools. But where's almost their objective view of whether something looks right? Because I think we all need, like when we're in professional meetings, you have to have a view of, does this sound right? Not just, it's come up with this figure, or it's come up with these reasons why Stevenage would be a good place for a 2-story building with solar panels. But does it sound right? And there's that worry to me, because I think we all need a bit of residual knowledge, and the point made by several of the speakers, including yourself, that we all need to keep on learning and not allow our mental abilities to degenerate. We can't just outsource the thinking to chat GPT.
Thanks, Joe. Those points are very poignantly made. Thank you very, very much. It's very true. And yeah, you're going to be critical about everything you get from these animals, because it will lie to you, and you've got to be very careful about how you use it. But as a sounding board, no harm. But bear in mind, as Joe says, it's got biases, and significant biases, which will be hidden from you.
And it can make you lazy.
And it can make you lazy.
And also can get you in professional trouble. Just very quickly, some of you may already know this one. In the United States, 2 lawyers put into chat GPT, tell me some legal cases to back up my argument, and it hallucinated. And what it did was it made up false cases, but then it went one step worse. It made up false cases that had never happened to support the lawyer's argument, but it assigned them to real judges. And so the lawyers were basically found to be guilty, I think, by their professional association of negligence. And the kind of ruling person or the tribunal made a very good punishment. He fined the lawyers, I think, $5,000 or something each. And then he said they had to write to each of the judges who had been wrongly implicated by chat GPT and apologize that they'd been cited by chat GPT in a case they never heard.
Hopefully when they wrote it, they weren't allowed to use AI.
Yeah, exactly. Yeah.
Just quickly as well, anecdotally, your comment about the AI being used to transcribe and summarize. Sometimes I join meetings with like contractors and all that, and they'll have like a personal note taker, and it's an AI one. And I'm sitting there, and there's the other AI tool, and I'm thinking, where's this actually? Who's listening in? Where is this going? And when you look at the terms and conditions of a lot of these tools, especially if they're free, it's just being used. The data's being reused for retraining. So I don't think people are very cautious with that, and as a result, it's a major data protection issue, which I've become very aware of. So it's just a comment.
So certainly those points are very valid, and
Steve, we're worried about time.
Yeah, and we'll close now. Any comments from anyone online? Okay, well, I just want to thank you very much, and thank Heidi. Thank you, Heidi, very much for your participation. And just want to thank everyone here for attending, and all 50, 60 of you online. Thank you very much for attending. Really appreciate it. Hopefully, any comments, send us emails and to us. Thank you very much.
Nice to meet you.
Nice to meet you, Joe, and thank you very much for taking leadership on that.
Well, we all contributed, so.
Thanks.